Hello everyone and welcome to our group project presentation on customer churn prediction using Knime and machine learning. Our team consists of four members. Number one, our team leader Arjit Mojumdar. Second one as me, Biswet Pramanik. Third one, Ruksha Kundu, and fourth one, Sudip Shao. Our object was to predict whether a customer will churn using real-world telecom data. The business goal is to help telecom providers identify customers who are at risk of leaving. Retaining existing customer is significantly more cost effective than acquiring new ones. Predicting churn enable proactive intervention such as offering discount which improve retention and customer satisfaction. We source our dataset from Kaggle which contains over 7,000 customer records including information like demographic, internet service, payment method and churn status.
After loading the dataset into Knime using the accelerator node, our first step was handling missing values with the missing value node. We ensured no rows with crucial data were affecting model quality by filling or removing them appropriately. Next, we used the column filter node to drop unimportant or identifier columns like customer ID, which don't contribute to prediction. Since some features were numerical and varied in scale, like tenure and monthly charges. We used the normalizer node to bring all numeric features to the same scale. This is especially for distance-based and weight-sensitive algorithms like logistic regression. Then we applied SMOT to address the class imbalance in the churn variable. Originally, the number of churned customers was much smaller than non-churned ones. SMOT created synthetic examples of the minority class to balance the dataset and prevent our models from being biased toward the majority class. We also perform visual analysis using the linear correlation node and a heat map. From this, we discovered that features like contract type, online security, and tenure had strong correlations with churn. Customers with longer contracts or online protection were less likely to churn. Insights that validated the importance of those features.
Once preprocessing was complete, we split the data using the table partitioner node into training 80% and testing 20% set. Then we applied two machine learner model for churn prediction. Regression. We use logistic regression learner node to train the model and logistic regression predictor to make prediction. This model is good baseline for binary classification and offer interpredictability. Second is random forest. We use random forest learner node for training and random forest predictor to apply the model on the test set. Random forest is assemble learning method that combine multiple decision trees and typically deliver high accuracy and robustness. After training both model, we use scorer node. Here the random forest scorer table. Here the random forest precision and here the random forest F measure and here the accuracy. Then we are going to logistic regression scorer. Here the logistic regression precision, here the logistic regression F measure and here the accuracy. And the ROC curve nodes to visual compare models performance through the area under the curves. Here the logistic regression ROC curve and here the random forest ROC curve. So export prediction using the Excel writer nodes and use the table view nodes inspect probability score like pre-charm equal to yes for individual prediction. I showing the table.
Now let's compare how both models performed using the key evolution metrics. In accuracy, we can see that the logistic regression has scored 76.66% and in the random forest it scored 84.70%. Random forest is more accurate by 8.4% including strong overall prediction and capability. As we can see the prediction in logistic regression is 78.43%, and in random forest it's 81.69%, meaning random forest shows higher precision, reducing false positive and improving target. Next, we can see the recall or the sensitivity. Out of all actual charmers, how many did model identify correctly? In logistic regression, we can see it's around 79.76%, and in random forest, it's around 89.45%. Clearly, random forest captures more actual churners, helping with early intervention. Now, let's move on to F1 score. F1 score in logistic regression it's around 77.30%, and in random forest it's around 85.39%. Random forest provided a more balanced performance, minimizing both false positive and false negative.
Based on our results, we conclude that random forest is a better model for churn prediction due to its higher performance in all major metrics. Business insights. Customers with month-to-month contracts, no online security, and low tenure are the most likely to churn. Random forest is the more trustworthy in identifying true churners without misclassifying loyal customers. This model can be highly valuable for telecom companies too. Identifying customers likely to leave, prioritize those for loyalty offers, ultimately reduce customer loss and increase profitability.
However, our result may be promising, but there are a few limitations in our project. Models that use default settings, no hyperparameter tuning was done. Feature engineering can be improved by adding interaction terms or behavioral data. Real-time deployment would need integration with customer-facing systems. Now, in conclusion, I would like to add the project shows how machine learning with Knime can solve real-time business problems. We build and complete a pipeline from data loading, processing, and balancing to model training, evaluation, and export all to the Excel reader. Despite some limitation, the project demonstrates a practical, visual, and effective approach to churn prediction.
Thank you for watching our project presentation. We hope this gave you valuable insights into churn prediction and data analytics using Knime.